Is that unmuted now? Is it? Yeah, okay. Thanks. The story with the keyboard is I'm not a keyboard enthusiast, but I had an unfortunate margarita incident earlier this summer, and I have a bad case of margarita keyboard, so that's why I have this keyboard with me. And so I struggled finding a title, and this is what I settled on. And it's really going to be talking about the things that I've been working on with my colleagues for the past 2 years, and how it's just kind of changed the way I think about things and the way I do a lot of things. It's kind of allowed me to do things that I just simply didn't think was possible. And it's been interesting. It's changed the way I interact with my colleagues, 3 of which are here today. The way I interact with designers, product managers, just product development in general. And so I'd like to just share some stories. This is a very different talk from the kind of talk I usually give. I usually do a lot of live coding and a lot of like the last conference I talked about lenses for a long time, and we're going to talk about lenses a little bit today. But yeah, I kind of want to just kind of tell some stories and tell about things that we've embraced that have helped us a lot, things that we kind of no longer found benefits from, and so we just kind of had to let them go, and then actually dive into some of our code and just mess with stuff. Yeah, so I think weirdly the talk really does kind of start with my teammates, and this is 8 people. It's a designer, a PM, and 6 engineers. The engineers range from junior to very experienced, including a former intern from this summer who is now a junior engineer. 4 of these engineers have contributed as much to Android as they have iOS. We kind of, on both sides, kind of just do all the same stuff. There is no difference. And it's kind of a story of how we mentored each other and learned from each other, and really just kind of try to insert a lot of interesting functional programming stuff while also having to prove to ourselves that it was worth it. And so before we can get into code and stuff, we have to describe some principles that we benefited greatly from, and they're the things that we continue to benefit from. In fact, things kind of pop up almost on a weekly or bi-weekly basis that we would have just never predicted 2 years ago. And we'll also maybe cover some principles that we do not benefit from necessarily. The first principle is the separation of effects from purity. And this goes in 2 parts. The first part is the isolation of side effects. So just a basic definition, an expression is said to have a side effect if its execution makes an observable change to the outside world. You can't avoid side effects, of course, otherwise you could never change anything. The goal is to make them understandable, because they are wildly not understandable if you just kind of sprinkle side effects throughout your application. An example of a side effect, changing a label's text. Of course we have to do this. We want to do it in a way that we can understand and control. And honestly, maybe we do this so often that we don't even think of it as a side effect. It's so natural, but instead if we wrapped it in a function, update, that took a string and a label, and you just crammed the string into the label, and then you called that thing, then this is, very clearly doesn't need to be wrapped in a function or anything. It's almost kind of hidden the side effect rather than made it upfront and obvious. Another kind of side effect we might do is to have some logic that then is kind of piped into a UI control, like a login button. It's enabled if the user text field and the password text field are not empty. And I think a way we would approach isolating this side effect would be to kind of wrap it in a function, and then that way anytime state changes elsewhere in the application, we would just have this one point to call to update the state. And now we've kind of put this side effect in this one little place, and maybe that helps us, but it doesn't really help us. And so an example of how we can isolate the side effect and make it obvious that this is where this unknowable, kind of non-understandable thing is happening, is to just make it a part of the way we code, to have this escape hatch into side effect land. And having seen Gina and Lisa's presentation from earlier, you would know how we might approach this, but also seeing, like if you've ever messed with things like Elm and even PureScript, and Haskell in general, they make it very clear when you're escaping into side effect land. And so the way we might do this is to lift changes in, I said user, all right, it's email now. So lift email and password up into the signals of values, combine those two signals and map on whether they're both empty or not empty, and then you observe that login button enabled signal, and that observe next is the escape hatch into side effect world. And in fact, we want to have no side effects ever unless they're in observe next. And that way, you can understand everything outside of these observe nexts, and then inside observe next is when you escape into the world you can't really test. Or, I mean, you can, but you can never be 100% certain about what you're testing, and we'll talk about that. We also, this is like pretty cluttered to just simply flip enabled, disabled, and so we've also written like little extensions that allow us to write it so that it looks like exactly what we did before, except we just had this one step put in between, and that just simply binds the signal to the enabled. And then, now this looks like old side effect world. So this was the first part of effects. The second part, and this is where category theory comes into play, is the surfacing of co-effects. All right, so we all know what a side effect is, and let's just call it an effect. What is a co-effect? Well, it's clearly the dual of an effect. I can just stop there, but maybe not. So it's like the dual notion. What would that mean? So the definition, honestly, I don't have a great definition, and this is a very active area of research, and I'll give some references later. But at the last functional programming conference, I talked about duality a bit because I gave a presentation about lenses, and then I just wanted to say that prisms were the dual to lenses, and therefore you should understand everything about prisms by just love everything we learned about lenses. So I'm going to give a definition with just kind of like an analogy, which is to say, if an effect is a change to the outside world after executing an expression, then a co-effect is the state of the world that the expression needs in order to execute. And a surfacing of co-effects would be surfacing to the function everything it needs to execute. That might kind of register something in your minds, because an example of such a thing would be dependency injection. Like, you give a function everything it needs. You shouldn't have it reaching out of the function. So here's a function that has a co-effect. It's asking, is the current user the creator of a project? Return a Boolean. And it reaches out into the global space, user.currentUser, and then compares these IDs. This is a pure function. Call it as many times as you want, and you'll never change anything in the outside world, but it has a co-effect. It is not provided everything it needs to do its job. So the obvious way to fix that is to give it everything it needs, which is to say now we will call the function user is project, and then you can just give the user. So the fix is easy, but I think it's instructive to understand these two very kind of theoretical sides of what makes a function effect and co-effect free. And I want to give, this is very exciting stuff, so I want to give some references. The last functional programming conference, Colin Barrett gave a talk where he dissected a couple of ideas from structured interpretation of computer programs, applied it to Swift, and one part was about the environment context in which you execute. And that is precisely what co-effects are. Also, this guy, Thomas Petrichik, he wrote his thesis called Co-effects, a calculus of context-dependent computation. It's kind of readable, but he also wrote a blog post, Co-effects, the next big programming challenge, and it's really fascinating. It's really cool stuff. He's got a lot of papers to read, and they're really cool. And this co-effect duality is exactly what prevents easy testing. If your function has side effects, the only way you get to test it is to execute the function, and then inspect the world, see what changed, and assert on that. You simply can only hope that you tested everything that could have possibly been affected. Like, you have no idea if something else was affected. If your function has co-effects, then the only way you can test is to stub the entire world in which it can execute, so that you know that the function is working in a controlled environment that you provided, and you just hope that it didn't reach into some other world that you did not control. And so if your function has both effects and co-effects, then this doesn't sound very happy. And we're talking about happiness in functional programming. And the really funny thing is, in Haskell, the escape hatch to side effect land is the IO monad, it's a really interesting thing. And this it's not popular at all in Haskell, but you can also model this co-effect stuff with the OI comonad, which I think is hilarious. But yeah. So that's our first principle, separation of effects. The next principle is something my colleague, Stephen Sellis, told me, which was to code to the interface you wish you had, not the interface you were given. Maybe this is like an adage that he just stole or something, but I don't know, I liked it a lot. I've never heard it, so I will attribute it to him entirely. And I gotta say, I think it can be a very frustrating experience to interact with an API that you do not control and to be beholden to the way in which they do things. And yeah, I think it doesn't make for happy development. And I think UIkit is maybe one of the biggest offenders just because it's what we use so much and we have no control over it. It's a large stateful API. It's built on imperative ways of doing things. Its paradigms are a little bit mixed even, notifications, delegates, blocks. It depends a lot on global state, but then they've kind of tried reining that in a little bit. Like, used to be able to just reach out for the device idiom, and now it's like this trait environment inside views. So it's like, there are ways in which it's being made better, but, we don't. We don't control it, and so what we want to do is find a way of using it in a way that we can be happy developing like an abstraction layer. We want to be as close to it as possible, and I think the way to do that is just functions. Like pure functions we understand, they're just infinitely understandable, so we want to I want to get this guy up on here. Maybe I should have waited. Okay. So yeah, by embracing just functions, we can transform we're happy with without feeling that we're building something gigantic on top of it. And so to flip this, we're going to analyze it by first analyzing the second part, which is the interface we were given. What's an example of an interface we were given? And it's storyboards. Storyboards, they have their pros, but they also have a lot of cons. And they are a very thick abstraction layer on top of UIkit. I mean, first of all, the file itself is not human readable. It's kind of a janky interface to interact with. It's not built for. It's built for getting your feet wet, not for building a long-lasting application, I think. And we actually use storyboards, but only for view hierarchy, composition, and constraints. If you look at it, it's just basically an unstyled mess that we think of trying to fix that in a different way. It also separates code from data. We have a very specific style guide of colors and fonts and grids, and all that stuff can't live in storyboards. It's not possible to extract that so that we control those constants. And it's constantly catching up to what UIkit can do. And that's what's unfortunate about it. In abstraction layers, it just prevents you from interacting with the thing that you want to interact with. And an interface we wish we had is lenses. And this is what I talked about last time, last conference. And since then, in less than a year, we have gone all into lenses because it's allowed us to embrace immutability in like a more user-friendly way. We can really sculpt immutable values in a very specific way, exactly how we want. And I'm going to give a very quick run through of what those are, which is you have an immutable struct. It's all lets. It's just a value type. And the way we do it is that every model gets a lens namespace in which it then gets access to every field becomes a lens. So the project name lens is a lens from project to string. And a lens is a pure version of a setter. So the getter just extracts out the name. The setter replaces the name of a project with a new string, but returns a whole new project. It doesn't mutate the project. And the way you interact with it, of course, is with operators. And this is the dot twiddle operator, which turns the lens, you dot twiddle it with a string, and now that's a transformation of project to project. What could it do but take a project, spit out a new project with the name replaced with advanced Swift? So if you had a project, you could pipe that through this transformation, and you would then, whatever project was, you would receive a new project with that name replaced in. And then you can chain and compose these lenses and transformations. Chris, I know you have a co-author, but I couldn't fit it here, so apology. Two. All right, then I definitely couldn't fit that. But yeah, you can chain these things. You could also completely extract out the two lenses and compose them without any reference to a project. And it could just be this abstract data transformation pipeline that can sit away anywhere and then be applied at any time. So it allows you to create transformations without actually having the data at hand, which standard getters and setters you can't do. You need the data to .get and .set on it. So we got great benefit of this. We used it everywhere. This is the way we test the very subtle edge cases that are very difficult to test for. We get to probe our data and just flip this one little thing, and now we are a first-time project creator who has never backed a project and is now looking at their dashboard, like very intricate, subtle things, all with keeping immutable data the entire time. We liked it so much that then we started experimenting with what would it look like if we applied lenses to UIkit. And again, lenses are just getters and setters. It is just pure functions. They are not, we do not consider them a thick abstraction layer. They can be unrolled very easily. So, I mean, just like sketching what I had done before, what if UIView had a lens and you could set the background color? So it's a lens from UIView to UIcolor. You could dot twiddle it with red color. Now you have a transformation from UIView to UIView that would just set the background color to red. Then you could chain them and you could set the background color to red. You could lens into the layer's corner radius and set it to 4. You could lens into the layer's mask to bound, set it to true, and now we have a red UIView with a 4-point corner radius. We could extract out those lenses so that they don't make any mention of a view, and we could have a rounded style function that just is ready to be applied to any UI view, and it just applies the corner radius mask to bounds. And now we get to apply that rounded style to the view and then set the background color to red. We could start creating a style guide out of this. We could have a base button style that is rounded and that its title label is 16-point font, its content edge insets is 6 points top bottom, 12 points left right. From that base button style, we could derive a green button style, which is simply the base button style, then applying a background color to the normal state. We could have a big button style, where now we have this other operator, which the dot twiddle just straight up changes the value in the view or value. The percent twiddle allows you to inspect the current value and then make a transformation of that. So here, $0 reflects what the content edge insets were when the base button style was applied, and the big button style is just going to double all that. It's going to become a big button. We kind of just started with this and just messed with it, and we just kept on getting kind of benefits from it. It allowed us to think of styling as a separate thing. It allowed us to develop a style guide that could be applied anywhere. We started having base styles for our controllers, our table controllers, our UI views, our table selection cells. And then it came to the time to make an adaptive layout, and it was like, well, the view itself knows what traits it belongs to. So again, why not use these lenses? And now we change our base button style, so its title gets to check if the button is in the trait collection of a vertically compact view, it's going to use a smaller font. And if it's in a regular view, it's going to use a bigger font. I mean, I think half of iPad development is just making fonts bigger and padding bigger, to be honest. Like, that gets you a long, long way. And the fact that we get to kind of extract this away and think of styling as its own world that we get to compose in infinitely many ways. And yeah, we use them to great benefit. And this is from junior to senior. We just keep finding new ways to understand this. And I gotta be honest, like the trait environment is very interesting because it's when Apple started kind of, at least I'm not very familiar with Apple APIs to be honest, but when I saw that I was like, all right, they're moving away from global state and they're injecting the state actually into the views, because now, you know, Apple TVs have dark mode, light mode, right? And so that means we get to localize those stylings in a very understandable way. All right, so those are things we benefited from. Things that we didn't benefit so much from, but we think these are like great principles. We just simply could not really hold ourselves to them anymore. We kind of found that they just kind of led to discussions that never really went anywhere. And it's kind of weird to let these go because I think they're ingrained in us. And I think they may be controversial, but I think functional programming allowed us to get rid of like kind of let go. Dry. All right. Yeah, I got to say, it caused us to prematurely extract things. And a pure function that just is well-defined in taking input and spitting out output, I don't really mind if it's been duplicated a few times until we find out how it should really live. And you know, we worked on pagination, finding like the proper functional way to do pagination, and we repeated it in multiple controllers. Well, back then we were doing it in Android, in multiple activities, and we just kept on doing it over and over until we like properly understood it. And I didn't mind repeating that because it was just pure functions. I didn't care. Like the logic was so understandable. And so it gave us the tool to not prematurely dry. I think functional programming gave us this. Single responsibility principle. Again, that's like it almost always boils down to like a personal preference of like, does this thing have too many responsibilities? Like each person has their own opinion, and it really just caused a lot of wanting to create extra files to hold logic when it could all just go in one file. And again, I don't care if a file has 2,000 lines of pure functions because I know I can look at one single function and understand it entirely. And I feel like that should be the goal, not like metrics of file size or responsibilities. And then solid, just in general, is like a lot of these just pure functions are just not applicable. It's a lot of those things you just don't worry about. And then the most controversial, but this conference, objects. I've never met an object I liked, I don't think. Even when we did the Android paginating thing, it's technically wrapped up in an object, but the object is basically signals that it then purely transforms into output signals. And in fact, the view model stuff that Gene and Lisa described today, it is the dumbest object you've ever seen. It's only an init that took an input and spit out these output signals. It 100% could be written as a pure function that would take a couple of signals and output a couple of signals. And in fact, that's how we've written one thing like that, and it totally works. There's no reason to have this object sitting there. And yeah, I think we just keep on applying pure functions over and over and over and benefiting from it. And what are some of those benefits? Well, a lot has been talked about by Lisa and Gina. Testing. We like our testing things that I just honestly never thought were possible to test, like very complex user flows without ever touching the UI. There's not a single UI automation test. It's like the flow of going to a project page while logged out, and you try to start the project, and then a modal comes up to ask you to log in. You complete the login flow, the modal dismisses, and we star without doing anything. It automatically stars and presents a dialog saying, you started this project. That entire flow is written in a very functional unit tested way of just like user input and inspecting the output. Something I never thought in my life, I don't think I just ever understood it, and I just, all the blank-driven blanks or blank-driven development things are also kind of cultish, but I don't know, it's like, it is fun, I agree with Gina, and it's also, it's strange. I sit with it sometimes, and we're not dogmatic about it. Sometimes we have time, sometimes we don't. But every time I've done it, it's caused me to like do the exercise of go through a flow and kind of understand it before I'm even like writing in implementations. I can just look at the designer sketch file and just kind of think it through, and it's a fun mental exercise, and I think I've always liked the code more when I've done it this way. Another like blank-driven blank thing, but I made this one up. Test-driven bug fixing. A bug report is no more than, like a misunderstanding of how logic should be hooked up. And I should be able to write a test of user input that generates that exact bug. And in fact, that's precisely what we do like pretty often. And in fact, I can go into the code from a bug report, write a failing test, and then just push it to a branch, and someone could potentially come fix it, although probably I would do that. And so that's been really interesting to see that. So just confidence around tests in general. And then once all this testing was in place, a pretty fantastic thing happened in which we were able to completely replace storyboards with playgrounds. All the benefits of storyboards, of having this like feedback loop, like playgrounds have this, but in order to use a playground, you want to be able to present a view in full isolation. So that means no effects, no co-effects. And that's what we kind of did. So this is a simple playground. But we started just creating all types of playgrounds. So here, this is the creator dashboard. I can go in and start messing with some, stats to see how this graph interacts. So here, it's gone above the goal of the project, and so it went up. I get a full global view of the entire thing. I can also go in and switch the language. I can see what it looks like in Spanish. And again, language is very much a co-effect. We always appeal to what is NS localizable string doing? What is that doing? It's looking at the system language. That's a co-effect. We extract it out. We want to control it. I could also go to the project page, which is it's the most important page in the entire app, of course, and it is very stateful because it has many things. Right now, I'm viewing it as a logged out person, but I could also be someone who is even backing the project. If I comment out these lines here, now I'm someone who's backed the project, and a lot of stuff pops in all of a sudden. You're a backer up top. My reward was bumped to the top and given a special treatment. If all of a sudden the product manager wants to look at this for someone in French, they can just go in and do this, and now they're looking at it in French. One thing I see is that we have a string that is not translated, but that's okay because the translators are working on the translations. So yeah, this now our development is not storyboards, it's writing a code, styling, Command B, jump to this, and see it live. Okay, so. But then you look at that and you're like, all right, if you have this playground, why would you not automate that and do screenshot testing? And yeah, it turns out we were doing that for probably a month until finally we just sat down and after just a few screenshot testing. Oh, you know what? Before I even show that, I forgot to show one of the cooler things about this, which is because we want to fully control our co-effects, I don't want anything to depend on a simulator. So of course, I should be able to look at this on an iPhone 4. And of course, there's going to be problems, including these stats are just too close to each other, so that should be something we should fix. Okay, so then there's snapshot testing, and okay. So then, yeah, we started doing this only recently, and this is the best thing I think I've ever seen for a designer, to present our designer with every language, every weird, complicated state that a project can get into, multiple devices and orientations, locales. We even just generate one-off screenshots that our designer is just particularly interested in so that she can see the progress. And then, yeah, we can like, here's some of those graphs that we were talking about of all the different states. Let's see. So here is the like actual when you're about to give money, and there's Apple Pay states and non-Apple Pay states, and if you're currently a backer or not a backer. There's German, there's different devices, it's all over the place. Here is the project page in many different states. It's just, yeah, there's tons of different things. There's even things if you're in a different country from the project, we show a conversion, and it only shows in that special case. And so there's a screenshot somewhere here that shows, oh, here it is, nope. Yeah, anyway, somewhere there will be that case. So yeah, then that just fell out of free once we got to that playground world. So that's kind of transformed how we were thinking about things. And then event tracking, like Gina and Lisa talked about, say this was something that I had never thought of until we just like realized it was possible. It's like event tracking is very important for business decisions. We should be able to track data and then tell our data team that we can prove that the way in which it's tracking, it's like actually doing that thing. And in fact, if you come to us and say this data looks weird, we should be able to write a test that fails and proves that our logic just wasn't correct. And I kind of realized that this was something, or I knew that this was a thing, but then I saw Brian Harris, who some people may know, he tweeted this and it kind of started a conversation in which a bunch of people kind of came over to our office to discuss it, in which he said, nothing wreaks havoc on a nicely architected code base quite like impression and event tracking. And yeah, I totally agree. This is how I always did things. I just tapped in, view did load, view will appear, button taps, track, just littered it everywhere. But as you saw in Gina and Lisa's talk, you have all of the input signals that are describing what the user is doing. You should be able to write your tracking as a representation of those input signals very declaratively and then test on them and make sure you're not tracking too much or too little. I think this tweet equally applies to accessibility, which is something that often is kind of put off into a corner until the entire product is done and then you go and get it. And it shouldn't be like that, and I do agree that it could lead to a point where you're just littering it all over the place without knowing, but we have lenses for all accessibility. We also have reactive extensions for all accessibility. You saw in Gina and Lisa's talk, they added accessibility as if it was like as natural as adding the score label itself. And yeah, and we write tests. For example, my colleague Chris, he needed to do like a activity feed for project creators. And the feed is structured as a date timestamp and then card, date timestamp, card, as a mode changing from day to day. And if we detect that the voiceover, the screen reader is running, we probably don't want that mode changing thing because that's a very visual representation. We probably want to just simply insert dates between every card. So we extracted that co-effect out. That's a global thing that we depend on. And we were able to write tests that proved that each of those cases do what we think they do and had screenshot testing to prove that it does what we hope it does. And so then accessibility, we get to think about it in a completely different way. It's not a nuisance. It shouldn't be because it's very important, and that was kind of interesting. And then maybe the most interesting result was like a newfound love for UIkit, in which I got to interact with it in a way that I got to code to the interface I wanted, not the one I was given. We did a lot of work on Apple Pay. Like most UIkit things, is a controller, you present methods, and you've got call obstacle and all these things. I just wanted to lift those up to signals, do some transformations, and output some stuff. And flow in a test-driven way, which is really strange to say because I don't know, a year ago I would have never even said the word test-driven, I don't think. And yeah, it's the type of thing that you can feel confident it works. If it doesn't work, most likely you just read the documentation wrong. And that is fine because, I don't know, it's not your API and you're learning. And then lastly, the happiness, the final result is just a better working relationship with product managers, designers, and engineers, where I can sit with and have her tell me the most subtle of UI experiences she wants, and I don't have to cringe at the idea that in this very specific state, I need to add like 2 gridded elements of padding so that these things don't bump up, and I can write a test, and I can write a screenshot test, and I can do all the things, and I know that it's good for the product, and I don't have to like fight with the designer in order to like convince her that's not necessary. And I can give the product manager tools so that she can more confidently, make decisions and talk with us in a way that we all have like mutual understanding of what our goals are. And yeah, and that kind of wraps up finding happiness in functional programming. It's been interesting, and just one other slide that will add one other line, which is that we are hiring, and if you're interested in such things, this would be my email. And yeah, and that's it. Questions?
Do you have anything to connect between the view controllers?
Yeah, I mean it's all just inputs and outputs. So each controller can just publish the things that it wants and publish the things it's willing to give. Not very unlike a delegate pattern. We've kept it lightweight, and that hopefully you're alluding to your functional view controllers. No. I've often thought about your functional view controllers. I've just never had like the spare time to dive more into it. But yeah, I would love to lift it into a world that makes it more obviously composable. It really is just publishing what it understands and keeping the public interface of the view controller so slim that you realize that those are the only things it can understand. And, yeah. Back there.
So first of all, thank you for the talk, and I have 2 questions.
Yeah.
Well, one is about your lenses.
Yeah.
So you write them yourself, you generate them, then what are you?
Okay, handcrafted artisanal lenses, but my colleague Stephen and I did get 95% there with code generation, and we just are simply under a couple of tight deadlines right now, but that is going to be the next part. Well, okay.
Is this code generation in Swift?
Oh yeah, it's in Swift. Yeah, of course. And it's just using SourceKit, figuring out the stuff that it needs to generate, because like things like structs get an automatic internal .NET, and it's literally like a script to paste the struct into a new file, do an extension, do .NET, and have the code completion just tell you what it needs to do, and then just generate a lens for every single one of those. And we got like nearly all the way there.
And second question is, in certain circles, there are people even very experienced that say, well, yeah, lens is a cool idea, but you don't get it. Like in Swift, you can just have mutable variables and structures that can be out in other structures that do that. Right? I could just have a function and say, make my browser button, right? And
dot. Yeah.
So how would you answer to the person that says, oh, you don't get it?
Yeah.
This is not Haskell.
Right. So Chris was supposed to give a talk to really be the counterpoint to everything I've said, and so we're going to have to wait on that. I would say the benefit that you just simply cannot get with ... is its composition. I want to have reusable components of transformations. I want to see when they compose cleanly, and I want to have that language. That language is invaluable. Like the composition is the thing that keeps on making these things pop out more and more. Every other week, it's just some other benefit we get, and it's composition. It's not, immutability is great and everything, but just seeing that is invaluable. Any other questions? Yeah. We're gonna open source a bunch of the stuff. We're just on a tight deadline now, but like all the UIkit lenses, all the regular lenses, it's really not even. I could put it all in a gist. It's like not even a real thing how small this thing is. But yeah, we would love to share it, and we're gonna share it very soon. Yeah. Well, all right. Maybe not the playgrounds themselves, but the idea of how to separate the co-effects, effects, and all that stuff to make it so obvious how you can just like work in playgrounds. Yeah. I will say, the things that we would love to share is that playgrounds do some strange things with that little embedded application that we've had to find workarounds for, but it's nothing too terrible.
Cool. So two questions. One with the lens, with expensive objects, like are you creating 5 collection views per se if you're like styling it in that way? Is that a real problem, or do you have special cases where you're actually just generating one view?
No, we have no special cases. We haven't run into a problem yet. Yeah, I got to say, one of the things one of the reasons I'd most like to open source is to simply get people who know more about this, and maybe tomorrow we can talk about, and I can just simply show what's going on. It's just simply not a concern at the level of the things we're doing. It's dozens or buttons or models which simply flow through just a few transformations. It just simply is not a concern right now,
Okay, that's great.
which is very fortunate.
Yeah. And then the other one was both presentations had that app environment.
Yeah. Oh yeah. That's our co-effect.
Yeah.
That's the surfacing of the co-effect. And you got to watch Colin Barrett's talk in order to understand. Yeah, to really get that.
Would you go into a little bit of like why have that big global app environment versus like dependency injection?
Yeah, sure. Colin is going to say it better than I possibly can. I think if I were to sum up the things he said, it would be that singletons, although supposedly evil, they've somehow survived this long, and maybe there is some merit to them, but they cannot simply be allowed to roam free. One way of wrangling is to just put them all together and refuse any global access other than in this app environment. And our app environment even stubs out or puts in NS locale, NS date. Like we want to have control over time and all these things. And the argument for why that is so different from dependency injection is that dependency injection is either lightweight, like default arguments, and you are now responsible for propagating that through other functions you call, or heavyweight of an abstraction layer that you either have to build and understand, or you're going to adopt someone else's thing, and that's just another dependency that I'd rather not have to worry about. I got to say, this app environment thing has just basically solved all of our problems, and it's literally a struct that wraps maybe 20 things, and I just don't things, and I just don't even think about it anymore. Give me anything simpler. No, it's just a struct. We can also do this tomorrow. So we get our API service. Anytime we want to do some like debouncing and delaying, we even stub that. If you want to pick out a still frame from a video, like an AV asset, that is a global thing you have to reach into. By stubbing it, I get to write a test that I plucked out the frame 5 seconds into a video and make sure, and I can have a version of it that times out, fails, never completes, and really figure out how that changes my interface. Like this is just basically an NS cache. Get that calendar. Config is just user config we download from the Kickstarter API. Cookies, that's just some global thing that I want to control. Current user. Oh, cookies because, wait, did someone ask why cookies? Oh, no, Lisa's just trolling me. Facebook, they want you to interact with them in a certain way, and I want to interact with them in our way. Here's voiceover. We brought we get to control whether voiceover is running. And of course, the default is that global function that you can call, but now we get to control how voiceover is. Koala is our analytics tracking, the sibling to Panda in Lisa and Gina's talk. This is the language that all the localized strings. This is why we get to control English, French, German, Spanish, so on and so on. There's about 20 of them. I could keep naming them, but yeah.
done when you test temporarily instead of an environment publicly.
Right, yeah, we're using that, yeah, absolutely. Yeah, it allows you to also just describe the flow of how the environment changes through a very complex like UI flow, and yeah.
So if you change your environment, do entities get notified?
So, I mean, we've just gone low like weight on this. Like we've decided that when the environment very rarely changes, basically, in a regular app. So it's mostly a mechanism for testing. And in the regular app, one of the only things that really changes is logging in and logging out. And we can find a far more light way to deal with that environment changing than making some large apparatus for any kind of change in the environment. And that's how we've gone so far, and it's benefited us so far, and we will just simply wait until it no longer benefits us to like address it. Okay. Thank you.